Hi, everyone. Thank you so much for joining us for the last of our name's Magenta Strongheart. I'm head of design and partnerships at SupplyFrame's Design Lab. For those of you who don't know, SupplyFrame is a parent company of Hackaday, Tindy, and Design Lab. If you want to learn more about that, feel free to check out our SupplyFrame website or any of our social pages. Before we get started, just want to do a brief introduction to the Dream Team program. This was the first year of this program, and we were so excited to be able to bring together our nonprofit partners and our Hackaday community to essentially put together this dream team that would address a challenge designed by CalEarth. So we're really stoked to see what they've come up with and their final solutions. And before we introduce our team and panel today, I'd like to give a huge thank you to our sponsors, SupplyFrame, DigiKey, Microchip, and ARM. Without their support of the open source hardware community, none of this sort of impactful innovation would be possible. So we are super grateful to them and excited to see what's come out of this challenge this year. All right, without further ado, I'll pass it off to Giovanni Salinas, our product development engineer for SupplyFrame's Design Lab, and he'll give you more context on the challenge we're addressing here today, and of course, introduce our wonderful team members and panelists.
Thank you, Magenta. Hello, everyone. I want to start by thanking our CalEarth panelists for being here today. Shifte Khalili, CFO, Bridget Butler, Executive Director, and Davide, CalEarth alumni. We are here today for the final presentation of the CalEarth Dream Team Challenge. The team itself had a few challenges to overcome, and we are very happy to see everyone here today. The team includes Samira, Alex, and Jason. Hello, everyone, and thank you for your dedication. Their mission was building tools for SuperAdobe DOMs that would help make construction more efficient and with less overhead. I am very excited to pass the microphone to the team, so the floor is yours, CalEarth Dream Team.
Thank you, Giovanni and Magenta, for the kind introduction and the opportunity. I'm Samira. Along with Alex and Jason, for the past few months, as Giovanni mentioned, we've been working on a few ideas, and this is what we have come up with.
By 2025, more than 1.6 billion people around the world will lack access to affordable, adequate, and secure housing, but 40% of the areas that need to be urban by 2030 do not yet exist. The UN Department of Economic and Social Affairs 2017 report predicts that by 2050, the global population will increase by 2.2 billion people, with 70% living in cities. With a global population and urbanization boom will come an increasing demand for concrete and increasing greenhouse gas emissions to go with it. The current solutions in play result in a construction industry responsible for nearly 40% of global CO2 emissions. Unless we rethink the build environment and reimagine the future of infrastructure, cities of tomorrow will become increasingly unsustainable, unaffordable, and socially unequal. But there are solutions. CalEarth have developed one in the form of a way to sustainably build homes from the very earth under them, locally and quickly. It's called SuperAdobe. We set out to help create a global trend for SuperAdobe homes by designing tools that make it easier and faster for people to build homes using the technology. We started by identifying the bottlenecks in the build process and noticed two recurring points. Filling the bags can be cumbersome and awkward. It requires 2 or more people and has to be performed at increasing heights as the build layers are vertically laid. To address this, we conducted research and developed prototypes to aid filling the bags. Physical planning also stood out as a consistent time sink. SuperAdobe domes are made by layering bags of compacted earth on top of each other. Each layer placement has to be precisely measured, which takes time and requires skill. To address this, we developed a measuring tool to offload the calculation and coordination required for bag placement from the people doing the building. After exploring a whole range of concepts, we narrowed our sights down to 3: a no-tech earth funnel, a low-tech pipe compass, and a high-tech Lidar compass. The first solution is the earth funnel. The earth funnel improves the ergonomics of handling and filling SuperAdobe bags by simultaneously providing a bag dispenser and a large, consistent target for earth loading. The earth funnel allows builders to simultaneously hold, fill, and lay bags using just 2 hands. The user preloads 1 layer of bag onto the funnel. With 1 hand carrying the funnel, the bag is positioned where it needs to lay on the wall. With the other hand, earth is loaded into the bag. The bag automatically deposits itself as it fills and gets heavy. The low-tech pipe compass allows people to measure the position of each layer. The pipe compass builds on techniques already in use by CalEarth in the SuperAdobe community to replace the most basic and accessible chain compass with a more purpose-built tool to speed up the measurement and bag placement process. A foundation pole is mounted in the ground, on top of which a vertical pole is placed. A horizontal pole is then added and can be slid up, down, back, and forth. A measuring device is attached to the intersection of the poles, which tracks their position. The horizontal pole is then rotated and traces the inner circumference of the bag layer. The Lidar compass takes this a step further, delivering a profiling tool that can be used to measure a physical structure against a digital design and provide pass-fail feedback on the structure's accuracy in real time using a visible laser, including as the structure is being built. The Lidar compass is simultaneously most complicated in construction, yet simplest in concept and usage. Builders place the device on the ground at the center of the dome to be built. After connecting a phone to the device via Wi-Fi, a template of the dome's desired cross-section can be uploaded in DXF format. The device begins measuring the distance from its center to each point along the cross-section line. Whenever the measured distance is within a certain tolerance of the DXF template, the compass fires a green laser to mark that the wall is in the correct spot. In this way, bag layers placed correctly will be lit up green, where bags placed out of tolerance will remain dark. In order to determine the proper placement of the next layer, the bag layer simply puts their hand in the plane of the measurement. When the hand is at the right distance from center, it will light up green, and that's where the bag should go. At this point, the project is reaching the end of its initial phase of development, but the concepts don't stop here. Our next step is to conduct field testing in autumn of 2020 to collect user feedback. Even now, it's clear to us that there are improvements to be made to the current designs, and we can only anticipate that even more potential improvements will come to light during this field testing. In that spirit of ongoing development, and with tremendous support from Hackaday, SupplyFrame, and CalEarth, all the work produced during this project has been published open source, online, for free, for anybody to use as they see fit. It is our team's intent to continue developing these tools long after the Hackaday prize leg of this journey ends, and we hope you'll join us in making them better and more useful for everyone.
So I'm going to start by speaking a little bit about the Earth funnel, which is the concept that I worked on most. So the concept behind the tool is that someone building can preload an entire layer worth of a SuperAdobe bag onto the tool. And then with one hand, they can hold and position the tool, position the bag where it needs to be. And then with the second hand, they can load earth into the SuperAdobe bag. Then as the weight of the earth is added to the bag, it automatically, this is very simple as well, it's just made from a laser cut material. And you just need one tool, which is a rivet gun, to assemble it. So it's something that could easily be ordered to a site, sent in the post, and then just assembled quickly on site using one tool. Could I have the next slide, please? Thank you. So after sharing it with the CalEarth community on the Facebook alumni page, I got some feedback suggestion development of this one earliest because we wanted to focus all of our efforts onto the concepts, which we'll explain later. So this one stopped relatively early in comparison to the others, but we still thought it's valuable to share what we learned so far. So the feedback we got so far was adding 4 handles to the tool, so it makes it easier to position and hold. Secure the rubber band better to stop it sliding off, which is a problem I experienced during testing. People would like an instruction manual which explains how to load the bag and how to use the tool. And people have suggested exploring different materials to find the right balance of strength, both softness for the bags so that they don't tear, and lightness so that it can be held properly. The fourth feedback point we got was making the funnel smaller. At the moment, the tool is very large, like 60 centimeters in diameter, but people suggested it could be smaller but still have the same functionality.
Thank you, Jason. That was fantastic. The next component, like you saw in the video that we worked on, was low-tech pipe compass. This addresses the need for a measuring tool, which actually gives information where the next bag is. Initially, we worked on something that was sliding member, and later we switched because of feedback from a very helpful CalEarth community to something that rotates. As you saw in the video, this one, the pros are it enables people to flatten it completely when it's on the side, and it enables the site to be very easy for maneuvering, because as an architect, I understand how complex the construction sites are. So this one being vertical as a single pole enables us to walk around the site and not have a horizontal member all the time interrupting a construction site. So that's one of the biggest pros of this one. And the other one being it's easy to attach and detach when you slide for different layers. You don't need any tools. It's just a screw that you can handle with your own hand and move it upwards and downwards. And it's affordable, robust. Some of the construction sites are very dusty, so this member is very good for that. What are the recommendations for the development of this one? Is the integration of the digital tool is not yet fully done. It needs to be incorporated. That's something for the following innovators to work on. And we have 3D printed files right now for the integration of the pipes and the rotation. These need to be converted into molds where high density polymer can be cast for it to be product ready, because you cannot give 3D printed files to everyone. The next one is you need a product designer who will enable this, and a rough estimate of $5,000 to enable this to become product ready in the CalEarth store.
And finally, the Lidar compass. So I'm happy to report, first of all, that it does indeed work. Maybe Samira, you could click play on that video. There's not much sound to go with this video anyway, but this is indeed a demo of the Lidar reflecting that my hand is in the correct position where previously it wasn't. It's a little bit tough to tell, but you can see that the wall behind that box is not getting painted, and my hand, when it gets in line with that box, is. In particular, this demo that you're watching right now is a simple vertical wall demo. So the design of the dome theoretically is actually just a vertical wall. It's looking for objects placed in line with a vertical wall based on like where the horizontal distance is. So effectively that cardboard box forms the start of the wall, and then it'll pass anything that's in line directly above it. So yeah, we can successfully measure geometry versus a model, in this case a simple rectangular room, and display whether the actual measurement passes or fails that model given the green laser. At present, this is basically a functional proof of concept. So it works, but it does need a fair amount of improvement in a bunch of different spots. In particular, DXF import is currently missing. Originally, we had discussed importing an arbitrary dome shape and size on the basis of a two-dimensional drawing in DXF format. That isn't yet successfully implemented. The overall design, as we'll see on the next slide, isn't quite yet self-contained, in particular because there are a bunch of features that still need to be added or modified. Like for instance, you see that the laser driver here is kind of scattered out on the bench. It needs to be reduced to its actual own module inside the product. Power still comes from an external source, and so on, a few things like that. And it needs some quality improvements as well. So you noticed that my hand in that demo didn't get painted perfectly. It wasn't only painting where my hand was and not anywhere else. There were some blips and incorrect lighting in that demo. That requires some improvement from the standpoint of both measurement accuracy. The algorithm we're using for measurement processing has some room for improvement, as well as feedback accuracy. So the code that's running on that module driving the feedback laser has room for improvement as well. And then above and beyond that, the single biggest quality of life annoyance as it stands is that the laser sort of flashes into view because it's only spinning once or spinning about 10 times a second. The laser effectively pulses on and off, which kind of leads to a little bit of confusion as to whether the laser is lit in that spot or will be soon or whatnot. That's a potential area of improvement as well. Let's see. This slide basically covers all of those points. And then the final next step, aside from functionality improvement of the laser itself, is releasing all of the design data to this point. So the code for the Raspberry Pi component of this, the actual Lidar measurement component, is already up on GitHub with substantial documentation in README form. And the code for the feedback laser as well is on GitHub. It turns out it's slightly more complicated to release a bunch of Fusion 360 CAD files, so that remains to be done. And assembly instructions and bill of materials and that sort of thing, besides that they're sort of yet to be finalized, given that some improvements need to be made anyway, also still need to be written up and released. And when those are ready, you'll see them on the Hackaday, Hackaday.io project page, where we intend to sort of centralize all of this documentation coming from disparate sources. And I think we can move on to the next slide.
So yeah, at this point, the project has come a long way, but we all intend to keep pushing it. The next logical step we see is doing on-site testing once that situation is possible with the pandemic and with availability of workshops. So we'd go and take the tools that we tested and give them to people, some who have experience, some who don't have experience building the structures, and get that feedback as well. Because everything done in this project is open source, this can also happen remotely and digitally. So because everything we're publishing is shared online, we can also get feedback from people all around the world without them necessarily using them. So the next step would be, whilst we're doing on-site testing, to let this sort of feedback loop happen where the information gets spread and shared, and then in a few weeks' time or a few months' time, like collect and harvest the feedback and the data that people have come up with.
We've spoken about this earlier. Our ultimate aim is to enable CalEarth to share these products in their store, so they can help everyone out there who's trying to self-build or is commissioning a large CalEarth SuperAdobe style construction. So as of now, you've seen us put all the products here, and we hope that with further open source community and designers and developers around there can give their input and help us achieve this goal. We would be working on this further because we're so passionate as a team to make it product ready and market ready. So just to sum up that, this is what we've had up until now. And in order to get market ready, you heard our team share what we need. And this is the product range that we envision.
Incredible work. I can't believe we ended up with so many. I mean, I can't believe it because that's sort of the nature, I think, of this this community and the ask when we went through the application process. But we really ended up with overachievers, I feel like, on every team, because not only did you present multiple solutions, but you all can't stop sort of talking about how you're interested in continuing the work, and you're not the first team to present multiple solutions. And I'm just really blown away by that. I think Gio and I think I can speak for Gio when I say that we didn't know, if every team would be able to finish one solution, let alone 3. So really awesome work. And I really appreciate your sensitivity to making, different levels of sort of high tech and low tech options, and addressing different aspects of the challenge of making these more accessible to build. So I'm really excited to pass it off to our panelists for our Q&A section, but amazing presentation, Dream Team. thank you. And also, I always appreciate the beautiful graphic design. So I'm going to pass it off on that note.
Sorry, I didn't see at the beginning of the presentation, and but I was aware of your work, and I'm actually very curious to try some of this equipment and to see the the limits and play with it and understanding how to improve them, and I can give my availability to if you will keep working on this to try what you have designed and to maybe go with you in a detail of some of these tools and go into the practicality during a building site. So there are some things that have to work, and so I'm actually very excited to give my input into all of this. So congratulations so far. That's very promising, actually, what I saw.
Thank you. Great to see you here as well. And yes, we were going to send you this incredible weapon, and thank you for your previous feedback. Because of that, now it can rotate from our discussions and diagrams, so it can go up or down and doesn't have to stay stationary. So that was a great feedback from you, and it helped our team get much further and make a better product for CalEarth. So we appreciate your time a lot, Davide, throughout the project and also ahead. And definitely this product, if the Spanish mail system lets me send it, looks like a weapon, but it will reach you in Italy hopefully soon.
Great.
Yeah, I'm really excited to see some of these now sort of in the test phase. We have a lot of people that I think would be eager to be your test subjects and try out some of these materials on their projects. You know, we have a whole community of builders who are always eager to try different techniques to try to, you know, improve the efficiency of the system. So especially obviously the lower tech, I think will be, you know, I think we'll have to think of the right person to try out Alex's tool that would have the technological skill set to really work with you and partner to get it right. And that would be something, I think you're in California, right, Alex? Is that true?
I am. And actually one of the things that excites me most is when you guys get back to in-person, you know, workshops and build days and that sort of thing. I'm excited to come out and try it in anger. One of the things that's a little bit tricky of sort of a technological sprint like this is, in order to actually get everything, you know, sufficiently functional end to end, there are a bunch of individual blocks in the design where like substantial improvements could be made and probably without altogether that much effort. But, you know, you just don't have the time to focus on really perfecting one block when the other 7 need to get done for end-to-end functionality. So I'm really hoping that by the time we have, you know, build days and whatnot going on in Hesperia, I can have a chance to crack at some of those things and get it functional to the point where we can actually try it on a site and see how it goes. Once the sort of obvious, you know, the laser feedback is an inch off here or whatever, once those sorts of issues are ironed out, which hopefully won't take too much effort.
Yeah, no, that's really great. And I think, Alex, you should just connect with Bridget offline because we do have some more activity happening on site. And, you know, I say the sooner the better. So while it's still really fresh in your mind to come and spend a day or two, you know, as soon as possible, we would love to have that.
Yeah, agreed. Especially now that it's no longer 97 every day.
Right.
Although maybe it still is in Hesperia.
Yeah, don't wait too long because it'll start snowing. So, you know, the high desert is a mysterious place.
I come from Maine. I don't see the problem with that.
Okay. All right, then. Yeah, and then Jason, I just wanted to say, I definitely think that the handheld functionality is going to be really, really key in figuring out the right sort of mechanism for it. I can see that one being the quickest and easiest. You know, we could throw it in a kit and just easily get it to anybody. Whereas Samira's, I think, is something that would be really great, that we could explain it to someone in such that they could assemble it themselves or buy the pieces. Or again, you know, your comment about mailing it to somebody, if it's not simple enough to mail, then it would be the same for us wherever we sent it. But I think it seems simple enough potentially to assemble, which for certain things, like even tampers, people aren't able to always buy them everywhere they are. So we've figured out ways to teach people how to build them using, you know, buckets and concrete and sticks and so on. So I think once you get it really dialed in, that would be great. But with Jason, I think, you know, that tool that you're proposing is something that could be packageable and shippable. So, you know, someone could order it from us or from wherever it's being manufactured and distributed. And that would be really, really easy, you know, and we could test that one all the time. I mean, we could get that one right just on the site, any person without any technical knowledge. I mean, it's just the comfort, right? And having it even in more than one size, depending on how big someone's hand is or something, right? I mean, it would be really cool to have options like that, depending on the size of the builder or, you know, whatever, the size of the bag. So I'm definitely excited to see that one in person and to touch it and actually see what it feels like. And I think our students will as well. So a lot of really, really great stuff here. And I'm excited to see it further developed, and let's definitely figure out the logistics of whether we can test it here in California or wherever all of you are. We have builders everywhere now, right? As you know, so let's keep this moving for sure. Thanks.
Yeah, it's pretty clear to me that the next step for each of these things is playing with it on a build and seeing how it works out.
It's it could be for the earth funnel, it can be easily just emailed to someone and then either laser cut or plasma cut. So it's like very, very simple to test both here and in California. I can email it to Alex or Giovanni, and then it could be made locally very, very easily. So yeah, I'd like to see it tested as well. See what people think. Be cool.
I'm curious. I have a question for CalEarth, and I'm sure that it may have been discussed amongst you all, you know, behind the scenes, but just so everyone who's watching has a better understanding, and me, I'm wondering, you know, what's the the interest or need for CalEarth? Like, if you were to have a useful amount of each one of these tools on site, what would the number be? And then how interested are you all in a mass-produced version for something like the web store versus, I think, you know, no matter what, we want to keep all of these things open source because it aligns with all of our missions, but that doesn't mean that there also can't be, you know, a distributor of these in addition to that. So if you were interested in mass production, how many or what, you know, what level of that would interest you all? Yeah, that's my question.
So I would say for the bag handle, that would be something probably would be the one that we'd be the most interested in mass production of, just because it would be the simplest and the sort of least likely to fail if the person doesn't really, you know. So the other two I think require a technical knowledge that we would really want to use more probably for our own teams or to be able to distribute amongst the people who have that higher level of expertise. So I don't know that I would necessarily want maybe the compass, once we're really sure it is accurate and that we can stand by it and it's equivalent to that chain compass. I think I just have to see that one more in person. And then Alex's tool would be something that I would probably only give to our highest level of expert instructors that we're sending out places, just because, you know, it's more I would say it's the liability, right, of us being able to assure that someone is going to use the tool correctly and that there isn't going to be, especially because Alex's is really about the measurement above all and that trusting the technology. So yeah, but I mean, I could see all three of them being something that, I mean, I don't really know, again, the costs associated with what it would take, but we don't want to mass produce it until we're really sure that it is something that people will use. And if it's something that people can simply make for themselves with the instructions that are open source, I mean, that would be great. But yeah, I mean, if there's a short run of each one for us to be able to send to all of our, you know, friends and family of the Institute who are really out here as the next phase, I think that would be really great, to really test it for us, you know, to field test it. That would probably be our best next step.
I agree with Shifta. I think that there is great potential for all three tools to be added to our inventory that we sell at CalEarth. However, I think the most exciting part of all of this is being able to get our team on the ground to use some of these tools and to give feedback. And I think it's based on the functionality and the success of usability that will inform us as to how feasible it is for us to offer and to sell these different tools. I think that the potential can be maximized once we really dial in the success in these tools addressing some of our pain points that we have. And that's why I'm really excited to get these tools in the hands of our guys and gals on the ground. They're very excited about using them. We've had many discussions at CalEarth. As I was explaining to Magenta before we started today, that we've started to add some more activity on site. And so we do have a very light program on site where we have our one-day workshop, for example, in December. So, you know, I would love to invite you, Alex, and down now to come and observe how, you know, we're working with these tools in terms of our teaching and our educational aspect of the organization. But everyone that I've spoken to in our community, and I'm sure you guys have also spoken to many folks in our private Facebook group, is excited about actually using and trying to see, you know, what questions and feedback they can give you on improving and further developing these tools. And that's really kind of my question, actually, is I'm not exactly clear about next steps and where we go from here, because everything you all have done, you know, has been fantastic, and I'm enthusiastic, and I look forward to us completing this process and seeing what lies on the other end of us finishing the work. So that would be great if I could get some information about actually what the next steps are.
Of course, and I'll jump in on this because it's something Gio and I have been discussing a lot the last couple of weeks, and we're trying to sort of prepare communication that we'll be sending out, you know, over email before the end of October to everyone. Of course, everyone, like I said at the beginning, you know, the wonderful part of it being open source is everyone is welcome to continue the work at whatever capacity independently, you know, or you all as partners and whatnot. But Design Lab would love to continue to support and be involved as much as possible. And part of my, you know, asking that what would be the most useful and sort of target number of an initial run for CalEarth, even if it was just to what you guys could benefit from on site, you know, for now, before we even think about scalability or mass production of any of the tools, is so that we can get sort of a goal in mind for Design Lab and working with the Dream Team members in the next couple months to see, you know, how we get to that number. So if you could use 3 Lidar compasses on site and, you know, 10 pole compasses and, you know, 10 funnels, then that's like a good goal for us, you know, a quantitative goal for us to work on reaching. And we're really excited to do that sort of thing. Sorry, what was that?
I would say less than that, because we're not ever building on that massive a scale. You know, it's going to be just a few people at a time testing the different equipment. So, you know, let's save the budget for when we're really ready, or if we can send maybe a couple to CalEarth and a couple of other places. So
right.
Yeah, we could do
right.
a
so
fun 3 of that. Seems like a fine number for us. And then we can pick a couple of people that we would want you to send it to elsewhere, or we can send it to them.
Yeah, I think the next step, as Alex, Jason, and Samira sort of outlined, is to get user testing on all of these things. And so I think, you know, it'll be up to them to determine what point the prototypes need to be, or the first versions need to be, to receive a helpful, and effective user feedback. And then we, come to a number on how many of those getting distributed would be useful. We sort of collect that data for whatever time is necessary, and then we can think about the numbers of like final, fully functional, working, no longer really prototype, final product kind of versions we can help you all produce. And then we can leave the conversation open for the larger quantities way into the future. We're really excited to have this foundation of a partnership with you all, and I think there's a lot of ways we can continue collaborating. So we'll definitely be following up before the end of the month about specifics around that. But and I think the Dream Team members, have mentioned they want to continue working on these things, and we'll also be working with them to figure out at what capacity and what everyone's schedule and bandwidth allows in the upcoming months. So
I'm going to say one last thought. As I was listening to you speak about the next steps, and thank you for clarifying for me. It sounds like I don't want to commit or speak, too soon about anything, because any of those three or all three of those tools has great potential. And I think we won't know until we get the community feedback. Because I may have an idea, or Davide or Shifta, of what may take off, but you never know, and so I'm excited, and I'm grateful to all of the Dream Team members for coming up with, as you said earlier, Magenta, not just one, but several solutions for us. The entire community is grateful to all of you. And I just want to say thank you again on the behalf of the CalEarth community for actually seeking us out, contacting us, connecting with us, and offering such amazing and inspiring help from some brilliant minds here. Thank you.
Of course, thank you, Bridget. And I just wanted to mention one more thing as far as the, the production and the next steps question. It's been interesting to see with all of our sort of final reviews and nonprofit partners sort of, are navigating this question of the benefits and, sort of the pros and cons of mass production versus distributed manufacturing. And it's something that's come up with all of the solutions presented. And it's really interesting just on, a broader context for us at Design Lab to see that. And, I'm just really excited that everyone's so on board with like a hybrid model of developing both, or thinking about both at the same time, because I think that it shows a really interesting sort of trend with product development, currently and likely to continue into the future, of the advantages of producing on site with the tools at hand versus having things readily available for people to order and have sent to them. And also, speaks to the really broad audience you all work with, of course. So very interested in what we're learning in that respect, and excited to support in all the ways.
Thank you, Magenta and Bridget. I just wanted to convey a message to the open source community who are probably watching this and are either really motivated or excited to contribute to any precious plastic combination with ability to manufacture molds makerspace out there. If you're watching this, please reach out. We would love to. They're parts of these devices where we as designers can send you files, and if you could manufacture the mold and use precious plastic machines to just press mold some of the parts, then we could ship at least 10 or 15 of just the top part of it to makers like Davide and others in the community, where the pipe they can install, which would be very, very easy for testing. And that makerspace, a combination of both, will help a lot, because right now I can't go to different makerspaces due to the pandemic. And at the Design Lab, we don't have in California the precious plastic machines which use recycled plastic into product. So if a combination of both exists in some makerspace, please reach out to us. We would love to collaborate.
And adding on to that a little bit, if you're out there watching this and thinking to yourself, man, I really want to get my hands on one of these tools, or, you know, help developing it or whatever, reach out via the Hackaday IO project page and get in touch with us, because quite frankly, hearing from people who want to use this stuff is probably what's going to motivate us to keep working on it and keep developing it and whatnot. And, you know, I want to see some of this stuff working in the field for my own reasons for sure, but you can definitely get a lot of my time by asking for help, like getting the code running or downloading files or whatever it is to work on and develop some of these tools. And I'm sure it's the same for Samira and Jason. So feel free to get in touch, you know, as quickly and as much as you like.
Yeah, it's exactly the same for me. If there's anyone out there that wants to test the tool, the files are all online, but if there's and like instructions are all online, but if there's anything we haven't made super clear, like don't hesitate to ask us, because then we can share. If we don't have the time immediately to do it ourselves and there's other people that are ready to like get going, then don't let that we can't hold you back from going ahead and doing it, because we're more than willing to help. Like, you could just have to communicate with us and we can.
Thank you. You all are doing my job for me. You're promoting. Of course, all of this is available on the Dream Team, CalEarth Dream Team Hackaday IO page. And we would love to see community support and, you know, anyone who's interested to pursue contacting us on those platforms and, you know, get involved. I want to give one last opportunity to everyone for any closing remarks, and then we'll go ahead and wrap this up. Want to be respectful of everyone's time on the call, but really, really awesome presentation. And thank you again for your dedication over the last couple months. We know it hasn't been easy. Like I said, Gio and I had all kinds of expectations that were exceeded beyond our wildest dreams here. So we really appreciate everyone's commitment on both the CalEarth Institute side and the Dream Team side. And we know that, you know, it's been sort of an insane year, just external context wise, for everyone to do this kind of work. So we really, really appreciate the enthusiasm throughout the whole process and commitment to this engineering sprint. Yeah,
same. I just want to thank, well, Marco is not here today, unfortunately, but thanks a lot to Marco for all his valuable and very technical input. You know, all his experience was very, very helpful for developing these ideas, and also some advice, but especially to the team, Samira, Alex, Jason. It was a pleasure working with you guys. You surprised me with a method. You were really able to create a method real quick, because you had to do a lot of research from the beginning. This was a project that was not you were not familiar with it, so you didn't just jump on it. You know, you follow the procedure, you followed your own method, and then you came up with 3 amazing solutions that were presented to CalEarth. CalEarth said, you know what, we like them all. So you developed them all. It required a lot of work, a lot of dedication, and I'm really, really proud of the 3 of you. Thank you so much again.
Thank you. It's been a pleasure to work for you guys.
Yeah, same to you guys. The whole program has been really nicely structured and delivered. It's really good.
Thank you. I share the same feeling to the whole CalEarth team and Giovanni, Magenta, and the support community. Thank you so much. It's been a pleasure.
And I can't wait to meet all you guys in person at the CalEarth build site.
I know, it's open invitation as soon as possible. Please, you know, well, Alex, I think we'll see you the soonest, but everybody else.
Probably, yeah, probably.
As soon as possible. We would love to have you come and apprentice and spend some time and really build out these ideas, you know. So just seeing your interest in this work is really exciting, and you know, we're thrilled to know that people out all around the world continue to find new and innovative ways to improve this technology. So thanks to everybody for letting us be part of this experience.
Wonderful. Well, thank you all again, and thank you for everyone joining in the audience for keeping along and following this project. we really appreciate the support. And of course, as we mentioned, a huge part of this is the communal passing on of the torch and continuing the development in all of the unique ways that we don't even know yet. So we're really excited to see what everyone does with this into the future. And again, I'll just reiterate all of this, all of the project documentation is available on hackaday.io. If you search for CalEarth Dream Team, you should be able to find Jason, Samira, and Alex's work. And if you want to follow along with our other programs and initiatives and what, you know, Design Lab, Hackaday, Tindy, and SupplyFrame are all up to in the coming months, be sure to check us out on Instagram, Twitter, and Facebook. And I'm sure the same is true for CalEarth, so I'll just plug that really quickly as well. You can keep up with all of their progress on all of their social channels. So thank you again for joining us, and congratulations to the team. We really appreciate all the work shown today.